Hello, welcome to Operations Management. In this lecture, I will try to solve a problem on forecasting using different methods, and I will try to determine the best forecasting method. So we have a week where the actual values or actual sales are these. And firstly, we want to use a naive approach to forecast. So according to naive approach, we use previous time period's actual value to forecast next time period. So Monday, if you see, we don't have previous Sunday, so we cannot forecast that. But to forecast Tuesday, we take Monday's value. So I will put equal to and select this cell, the cell of Monday, actual value of Monday, and hit enter. So that is 20. And now if you see, once I did that, I will go to this corner and wait for this to become a plus sign and then drag it. So those are my forecasts. So if you want to cross check, Wednesday should be 30, which is Tuesday's forecast, actual value, Tuesday's actual value, and then Thursday should be Thursday's forecast should be Wednesday's actual value. So that's how we will have the forecast for Monday to Friday. So now I'm trying to determine 3-period moving average. So 3-period moving average means we take the average of previous 3 time periods. So we need to predict Monday, we need Sunday, Saturday and Friday of the previous week, which we don't have, so we cannot forecast that. Tuesday, we have Monday's value, but we need Sunday and Saturday, so we cannot forecast that. Now Wednesday, Wednesday is, we want to forecast Wednesday. We need we have Tuesday's value, we have Monday's value, but we need Sunday, so we cannot forecast that. And then Thursday, we have actual value of Wednesday, Tuesday and Monday, so we can forecast that by taking the average. So the average, I'll select average here of previous 3 actual values. So I can again drag this. You will get the average of previous 3 time periods for Friday, which is Thursday, Wednesday and Tuesday. So these are the forecasts for using 3-period moving average. So now they're asking us to calculate 2-period weighted moving average. The weights are 0.8 and 0.2. With highest weight we will give to the most recent one. So 2-period means we need previous 2 time periods actual values to forecast Monday. So the actual values of Sunday and Saturday of previous week is not available, so we cannot forecast that. So then Tuesday we have Monday's value, we need Sunday's value of previous week, so we don't have that, so we cannot forecast that. Wednesday we have the actual value of Tuesday and Monday, so we can forecast that. So that will be, so we are giving higher weight to the most recent day, so that is 0.8 multiplied by most recent day is Tuesday, so I will give more weight to that. I will select that cell and then plus 0.2 times the weight of the actual value of Monday, so that is going to give us 28. So I can drag it again. So if you see, the formula works well. 0.8 times Wednesday's value plus 0.2 times Tuesday's value. So these are the forecasts using 2-period weighted moving average. Now they are asking us to calculate exponential smoothing. I represented here by using ES. The alpha value is 0.4, and then the forecast of Monday is given as 10. So if you see the exponential smoothing formula, I suggest you to go back. It is equal to, it should be the previous time period's forecast plus alpha, which is 0.4, multiplied by the previous day's actual value minus the forecasted value. So you can select those cells. So once you close this and hit enter, you will get the value, forecasted value. So I can again drag this, so I get this forecast. So if you want to cross check, you can see F4 is the previous forecast plus 0.4, B4 is the actual value of the previous, so that is the B is the column and 4 is the row, minus F4. So that formula works pretty good. So now we have these naive approach and 3-period moving average, 2-period weighted moving average, and exponential smoothing. Now we wanted to determine which is the best model for our data set. So that's what the decision makers or managers are interested in. They are not interested in all the models. They are interested in which is the best model that fits our company's data. So to do that, I will use MAD. So if you see here, we cannot predict this one, you cannot predict this one, these three, you cannot predict these two. So the only thing is you can only predict these. So we will use only those time periods, because the others are, you cannot use them. So if you have a lot more data, it becomes you get a lot of data where you can compare them. So at this time we will just compare these two rows for our prediction. So the MAD, as the name specifies, you can go back and see the formula. It's a mean absolute deviation. So you are looking at the absolute value and you are taking absolute error, and then you are taking the average of them. So the absolute error can be obtained by you can type ABS, which is absolute, and then the error is actual value minus the forecasted value. So you are using naive approach, so I will select the forecasted value of naive, that is C5. So I will close the parenthesis and hit enter. So the error we made is 20. It makes sense. See, actual value is 35 and you forecasted 15, so the error you made is 20. So if I drag this, the actual value for Friday is 20 and you forecasted 35, so the error you made is 15. So now I will take MAD here. So now I have to take the average of these two, so that is I will just do average and then select these two. I will get 17.5 for naive approach. Now MAD 3-period moving average, again the same thing. I will take the absolute value deviation. Now I am comparing actual value, which is 35, minus I am comparing with 3-period moving average, so I will select 21.66. so that is going to give me the difference is 13.33. So again I can drag this, go here and wait for the cursor to become plus, and then plus you can drag this. So again, the average value of this would be, take the average of these two, and then it will be 10. So how about MAD to WMA? So now again I will take the absolute value and then take the actual value minus the 2-period moving average, which is this value, and then hit enter. So the error we made is 17. So that makes sense, because 35 minus 18 is 17. And then we can drag this. So actual value is 20, and uh, the 2-period moving average, your forecasted value is 31. So the error is 11. So again I will calculate average of these two, is going to give me 14. So the final one is exponential smoothing. I will again do absolute error or absolute deviation. So I will do ABS, which is absolute value, actual value minus the forecasted value under exponential smoothing. So that's going to give me an error of 16.76. Now I can drag this again. So if you click on this again, you can see it's selecting the right cells, right? 20 actual value minus 24. So that is 4 point. So now the average of these two would be 10.852. So if you see out of these four, the average error is here is 17.5, 10, 14, 10.82. So the minimum error, if you see, is the 2-period, the 3 period moving average. So that's the best model for our data set. So we can conclude that exponential smoothing is best. So we might need more data to confirm, but at this time this is how the basic concept, which model to select, you can do by using MAD, and start predicting using different models. So the thing is, the manager would select exponential smoothing to predict, to make his predictions compared to all the other models. This concludes my lecture on forecasting. Thank you.